Hello, I'm Pierre Tagnou from CEREMA. CEREMA is a public body in charge of risk management, sustainable development, mobility. And I was supposed to have this talk with my colleague Erwan Broq, but he couldn't come this morning. At the time to take the plane, he had to bring his wife to the hospital as she was having a baby a few weeks ahead of schedule. Well, Erwan and I are in a team in charge of traffic management and intelligent traffic systems. And as part of intelligent traffic system, there's of course the problem of network security. So today we will speak about a hack. We will try to have a silent wire hacking. So why wire hacking? You may know about TCP hijacking or some 802.1x bypass techniques, such as what was presented by Valérian Legrand last year in this conference. Well, there are many ways to exploit the man-in-the-middle position, but usually you are not given the recipe on how to take this man-in-the-middle position. You know how to exploit it, but not how to take this position. So what we want is to connect something on Ethernet 100 megabytes cable in order to take this man-in-the-middle position without any warning in the supervision. No SNMP traps, no warning. This will be a silent wire hacking. There are such wires interesting for any hackers anywhere. Outdoors, you can see wires for CCTV systems or many things, or indoor cables from ground to ceilings, everywhere in buildings, in facilities. You can have some wire on which you want to connect. So let's consider a typical situation. You have a legitimate network with, in this case, a CCTV system and a supervision center. In this supervision center, you both have the CCTV central system and network management center. As an attackant, you may want to take the man-in-the-middle position on this link. So that's the problem, how to do this. If you only try to disconnect any equipment and take connect yourself instead of this equipment, or any way to any simple way to connect, it will probably trigger an alert. Because the link are monitored, what is usually monitored is the link status, whether the link is up or down. On the switch, you can activate this monitoring. You also have some protocols which give you information on the network topology. For example, RSTP. If you insert a new RSTP switch in the network, you will have a change. The distance between switch will be changed. You also have LLDP, which will inform you on equipment on the network. And of course, you have filters on MAC address or IP address on the switches. And you also have 802.1x protocol to enforce security. But as you know, once you have taken the man-in-the-middle position, this is no longer a problem. So we looked at some available solution. As available, I mean easily available on the net. You can find some TEP, so that's device to listen information on the network. But you cannot connect those tapes without interrupting the network. With probes, it's possible to not only listen but also inject some traffic on the network. But the setup of the probe also interrupts the network. For fiber optic networks, you know that by binding a fiber, you can have some part of light which leaks out of the fiber, and you can receive this light on another wave, on other fiber. So you can listen to a transmission, but you can't emit any signal on the link. So it's probably possible to have some dedicated hardware, but the solutions aren't publicly available. So you may choose to design your own custom switch. You go back to standards, you have a look at the 803 standards, and you have a look at datasheets, and you can try and build your own device. It's a bit complicated. We are looking for something which can be more easily done. So our goal is to take this man-in-the-middle position without warning the switches. And it should be a very simple solution that anyone can do at home, do it yourself. And a low-cost solution. By low-cost, we mean about 2 or 3 hundred euros, depending on what you already have. So the choice, as you have to connect to a physical signal, you may think to using some operational amplifiers on some classic circuit you may have learned when you were at school. But classical components you use when you were at school have a low bandwidth. If you want to capture an Ethernet signal, you need higher bandwidth components, and then it moves to surface-mounted components. As we wanted something that anyone can do, we limited the solution, no surface-mounted components. We decided to use only relays to manipulate the signal and to manipulate data with some raspberries. The first step is to intrude the wire. So opening the wire, that's quite easy. Splitting the pairs. The best tool we found for pair splitting is but a pen. And then connecting to the wire, you can use some contact. This is a contact you can find on some Ethernet sites such as Conrad or things like that. So it's quite easy to have the physical connection to the wire. You have the connection, but not you cannot use this yet. When you've taken this position, you can gather some information. What are the MAC address, IP address used on this network? What is the speed of the network? And identify some protocols, RSTP, LLDP, or some applicative protocols to know what you will have to hack. To gather information, you just connect 2 wires to a switch. So you have a dedicated switch, and you connect only the 2 listening wires to the on the switch to the first pair on the cable. You gather some information, and then you connect this to the second pair to have information from the other end. You have many information at this point, but the use of wires is negotiated between the 2 legitimate equipment. So at this step, you don't know what you have captured on the first or the second pair. So you first have to know what you captured, what was the use of each pair, which equipment was transmitting or receiving on each pair. So you don't know if you are transmitting and receiving on either pair because of the auto negotiation, auto MDIX or auto MDI on both equipment. So the first problem is this RX text and identification. So how to do this without signal comparators or any difficult to use component. By difficult, I mean component that would need to be surface mounted. In fact, we have a very simple solution by just using just two light emitting diodes and two resistors. In this position, you will have one LED which will turn on and the other will keep off. Because the signal sent by the equipment has a certain level, when passing through the resistance, it's dimmed, and it won't be sufficient to turn on the light. So one LED is on and the other is off. So you know in this example that the camera is emitting on this pair and the equipment is receiving. So by inserting those two resistance and diodes on one pair, you know where is the emitter on this pair, and on the other pair it's the contrary. So with this, you are able to identify the use of the cable, and then you can know which IP address, which protocols you captured on the first part belongs to which end of the circuit. The second problem is that if you just connect the two emission pairs of your attacking device, it will collide with the legitimate traffic, and it will induce a renegotiation of the port between the two legitimate equipment. So you cannot send traffic by just connecting to the wire. You need to have some equipment. So how to connect this equipment? We need an equipment to inject traffic. We need some electronics. So how to place this equipment? If we don't want this equipment to be detected, at the first part, this equipment will be connected in parallel to the circuit we are hacking. And so it is not detected. The circuit is still intact. Then we can cut the legitimate wire, and the circuit is still not modified, as we are passing through a short circuit in our equipment. So at this time, we can prepare the connection of our attacking switches. In the second step, we identify the use of pairs, so we can know how to configure our switches to connect to the pairs. In fact, one equipment will be used when one link is straight and the other one is crossed. So the two switches are pre-configured for a straight link, and we will have to cross one of the two connections. So we can switch, we can connect from the legitimate link to our attacking switches. So for switching, well, we will just switch from, with relays from one position to another. With relays, the switching time is of about 5 milliseconds, and it's too long, it would be detected. If you are using some MOSFETs, well, we will have some surface-mounted component probably, but the switching time will be much quicker. But with relays, it's 5 milliseconds. And 5 milliseconds is too long this link down will be detected by the legitimate switches, and an alert will be, a trap will be raised. So we want to modify the switching so that it can be detected. So how to do this? Well, you can do this by adding some another signal. In fact, we will add another signal which will be low enough to be considered as a noise during the first part, when the legitimate signal is still on, and it will be just sufficient to keep the link up, and then it will be the legitimate signal. So this red signal is a signal produced by your attacking switches. So that was what we tested, and we made the proof of concept in a few weeks ago. It was okay. We proved that it could work. So we have made the proof of concept of each step we mentioned just before, and then we designed our apparatus. So we began card design, welding, and counting strip and checking, but unfortunately it didn't work, and we were a bit late. So we hadn't time to completely fix it. So the full design of the apparatus still has to be confirmed, but each step was proved previously. So we can have a demo. Also the total device is not available. We planned to have a full demo with my colleague, in which we would have taken the man in the middle position and then exploit this position. But it was supposed to come with a part of the material, so I won't be able to do the demo alone. I will just show you some a few videos we made before. So this is the part of wire identification, identifying the emission and reception pairs. So here we have, this is the PC, the monitoring station, and here we are listening from trap from the switches.
The traps from the two switches.
And if the link is up or down, there should be a trap.
Purge those traps.
So in this example, those are the two legitimate switches.
Okay.
If we disconnect the link,
two switches or devices
then
connected,
we have SNMP traps on the monitoring station.
Which switch sends or transmits?
So let's purge those traps and move to the rack. Well, here we are connected on the link.
One LED turns on,
and we will try and identify the use of each pair. So we will move this potentiometer and progressively raise the resistance till one of the LED will turn on.
Was raised.
So in this case, we have the first LED which turned on. So we know which which equipment is emitting on which pair. In this case, the first equipment is emitting on this pair. There was no trap during this part. Now let's have a look at the drag from the insertion in the wire. So here we are cutting the wire. We are on this wire between the two legitimate switches. The first part is to open the cable. to have an access to the wire. So as the the complete device is not working at this time, we have the two steps, cable identification and the other steps are separated. So you must be careful on not to cut the wires. So the tool for splitting pairs. And the connection and the vampire connection. So you may know those tools if you are using some phone lines. That's what is often used to connect phone lines. First pair is connected. Second pair. So now we have a first point of connection. We need 2 points of connection, and we will take the man in the middle position between those 2 points. So we are preparing the second connection. So let's vampirize the wires. Oops, this is not the good wire. The pair order was not, there was a mistake in the pair order, so he has to remove this connection and do it again. The white green is the third wire to connect, and the green one last. So at this point, there's no trap in our supervision center. And we will connect to the switching device. So at this point, the legitimate link is still intact, but we are just checking that the physical connection didn't trigger any warning on the legitimate switches. And now we can cut the legitimate cable. And still no trap. So at this time, the signal is going through our device, but we are not yet in the man-in-the-middle position. It's just we are just bypassing the cut cable with the device. And now we will switch to go to our attack switches and use the man-in-the-middle position. So we will turn the relays on and take the position. And well, we have between our two attack switches in this situation, we have another device in the same network address as the legitimate network. This is it's pinged in this window, so it was unreachable before we turned our relays on, and as we turned our relays on, this device in the middle is now on the network. And the legitimate link is still up. We are still pinging objects on the legitimate link. So we are in the middle. The link is still, the legitimate link is okay, and there was no trap. No detection by the switches. The supervision couldn't see our intervention. Thanks. So the full device should be a bit more complicated, as you see, but we have proved that each step is working, and we could take this man in the middle position. So there were four ideas in this hack: the way of electronic insertion, the way to identify RX and TX wires, the switching to some pre-configured switches, and the use of a copy of a dimmed copy of the legitimate signal during switches to avoid the detection of the connection, the commutation. The cost, well, the component cost is about €80. To exploit the main in the middle position, we are using some Raspberry Pis, and the Raspberry Pis will also manage the sequence of each step in the full device. So that's why there were two Raspberry Pis, and we are also using some manageable switches. And we also used candies, almost €5 of candy to keep morale when things were not always okay. So that's where the cost, and of course, hacking is priceless. There are some possible improvements. The first one is to complete the circuit and test, complete the test. It might be possible to do this hack without the two attacking switches. You should configure the Raspberry Ethernet cards, but we didn't want to spend time on this hardware configuration. It may be possible to use one Raspberry instead of two. We have prepared some scripting for performing each step one after the other, but we still have no scripting to use the information we gathered in the first part to prepare the IP and the EB table. So it could be possible to use to script this part of the rack also. We also had some problem with multicast. In the live demo we intended to do, there was a camera, a CCTV camera looking at some object, and we wanted to spoof the video to still have the image on while we are stalling the object. And we had some problem with multicast. We were not able to use multicast switching on the Raspberry. So we had to move to unicast when we prepared this. The power of our Ethernet is not implemented in this version, but it should be quite easy. You just have to add some magnetics to separate the power part, which is on the common mode, and the signal part in differential mode. So we have proved that it's possible to take the man in the middle position without any supervision warning. So how to cope this? Well, you could add some device to detect impedance variation or something like that, or to have a detection, more accurate detection of link up and link down. But for infrastructure operators, it's probably not a good solution, as there are many electromagnetic perturbation and more. If you have very sensitive detection, you would have many false alarms. So we think that the only good solution is end-to-end encryption. Thank you for your attention. Yes, it's okay. He asked me how to insert the two light emitting diodes on the two resistors. Well, let's back. Well, in fact, when we have several relays keeping the line continuity in the first steps. In fact, we have two banks of relays. One which just keep the line continuity, and another one keeping the line continuity through the two resistance and diodes. So the first relays are keeping the line in short circuit. The second one, we are having the two resistance. So it's as it's an adjustable resistance, the resistance is 0 at first time. We open the relays, the short circuit relays, and we are through the 0 resistance, and we raise the resistance till the first LED will turn on. And if you push this resistance too high, then the link will go down. So just as you can see, when you can see light on one of the two diodes, you turn the resistance back to 0, and you reconnect the short circuit relay. Yes.
How can you say that it's silent as you have released a full ping process? So you have released ARP exchange. It's not so silent.
Well, in this case, it was easy for the proof of concept to have this device in the middle detected from the same on the same screen. But of course, when hacking, all attack switches and device in the middle would be pre-configured with ARP tables, so that they won't limit anything on the legitimate circuit. We will just redirect the legitimate traffic we want to modify with the IP table and the EB tables on the Raspberry attacking.